Hello, and welcome to the third video in our series about the concept of nomenclature in chemistry. Nomenclature is, of course, a fancy word that just means naming stuff. In this video, we're going to learn how to name an ionic compound containing a polyatomic ion. A polyatomic ion is a group of atoms bonded together that function as a single unit. And as the name suggests, these are ions and they have a charge. So the whole group of atoms that are bonded together carries a single charge. Now, from that description, you might think that polyatomic ions aren't something that we come across very often in chemistry, but they're actually fairly common. In fact, we've already seen a few polyatomic ions in some of the labs that we've done this year. For example, NO3 with a -1 charge is nitrate. SO4 with a -2 charge is sulfate. And OH with a -1 charge is hydroxide. There are many polyatomic ions, but there's only a handful that we'll come across commonly this year in our study of chemistry. So we've put together that list for you, and the link for that list is in the description of this video. If we look at this table of polyatomic ions, you'll notice that each ion has a defined formula, a specific charge, and a specific name. You'll want to use that list of polyatomic ions as we practice naming ionic compounds in this video. The main thing to remember about polyatomic ions is that they're always the same. And what I mean by that is, anytime we see an NO3 in an ionic compound, we know that that is a nitrate, and then that nitrate has a -1 charge. So these polyatomic ions always have the same name and the same charge. And the other rules for naming ionic compounds that we covered in the first and the second video in this series apply here as well. So, for example, let's talk about how we would name the compound CaSO4. Since Ca is calcium, I know that that metal keeps its name, calcium, and SO4 is a polyatomic ion with the name sulfate. So the name of this compound is calcium sulfate. Let's look at another example with a transition metal. So FeOH3. So iron is a transition metal, so I know I need to include its charge in the name. So hydroxide has a -1 charge. There are 3 of them, so I know that the iron needs to cancel out the -3 charge. So my name is going to be iron, Roman numeral 3, to specify the +3 charge of the iron. And then the OH is a polyatomic ion with the name hydroxide. Iron 3 hydroxide. Now it's your turn. Pause the video and name this compound. Okay, so in this compound, Mg is magnesium. So I know I just need to name that metal. And PO4 is a polyatomic ion with the name phosphate. So the name of this compound is magnesium phosphate. If we're going from the name of an ionic compound to its chemical formula, we just need to remember that polyatomic ions always have the same chemical formula. And we're still going to use subscripts to balance the charges of the polyatomic ion and whatever it's bonded to. And we might need to add parentheses around the polyatomic ion to make it clear of what that subscript is modifying. So for example, let's write the chemical formula for lithium carbonate. So lithium is Li, it's an alkali metal with a +1 charge. Carbonate is a polyatomic ion with the formula CO3 and a -2 charge. Now these charges don't balance, so I can use the crisscross method in order to get to my chemical formula. So in this case, the chemical formula of lithium carbonate is Li2CO3. In our second example, we're going to write the chemical formula for calcium nitrate. So calcium is Ca. It's an alkaline earth metal, so it has a +2 charge. Nitrate is a polyatomic NO3 with a -1 charge. Again, I need to use the crisscross method to write the chemical formula. And in this case, I want to also add parentheses around the nitrate so that it's clear what my subscript is modifying. So I'm going to do parentheses NO3 2, because otherwise it might look like I mean 32 oxygens. Now it's your turn. Pause the video and write the chemical formula for this compound. Okay, so this compound contains copper, which is a transition metal, and I can use the Roman numeral in the name to determine copper's charge. Copper has a +2 charge here. Sulfate is a polyatomic, so SO4 with a -2 charge, and those charges do cancel each other out. So my chemical formula is CuSO4. Now you might remember copper sulfate from our physical and chemical changes lab. It's the blue substance that we used in one of those tests. If you want more information, check out section 9.2 in your textbook. Watch the other videos in our nomenclature series.